Hi, everyone. Thank you for joining us today for this webinar. Jason Allen here, the Concrete Pipe Guy. I'm the Technical Resource Engineer for Oldcastle Infrastructure in the Mountain West, and I will be moderating today's webinar. Our topic is resilient infrastructure, and it will be presented by Trevor McDonald, who is the Director of the Mountain States Concrete Pipe Association here in Utah. Some of you may not be familiar with Oldcastle infrastructure, so I'll quickly share with you some of the solutions that we can provide. In Utah, when people hear Oldcastle, they typically think of reinforced concrete pipe, manholes, catch basins, and precast box culverts. But that isn't all that we do. We have a lot of new products that can hopefully help you on some of your upcoming projects. Our newest addition in the Utah market is gasketed box culvert. And instead of soil-tight mastic joints, we now manufacture gasketed box culverts to provide a watertight joint without any additional joint treatment, which saves time and money on installation. And we are very happy to announce Kudo, which is a modular underground stormwater detention storage system. Now, these HDPE cubes are HS20 traffic rated and are great for shallow or deep underground detention. Each block weighs about 20 pounds and uses 95% of its volume as storage, so you don't lose capacity to gravel backfill like in other systems. And this reduces the overall footprint of your storage pond, and it also makes for very easy installation. Another stormwater solution is storm capture. This is a great option for deep underground detention storage, typically between 6 or 14 feet. And this system uses the strength of reinforced concrete to provide more storage volume, so you can have a much smaller footprint than some of the other options that you may be used to. We also have multiple stormwater treatment system options like sediment traps or hydrodynamic separators that can fit your specific needs and stormwater treatment requirements. So as I mentioned before, our presentation today will be given by the Director of the Mountain States Concrete Pipe Association, Trevor McDonald. Trevor has been the Mountain States Director for almost 2 years now. Prior to joining our association, he was a municipal engineer for 8 years, and before that, he worked for a few years in the private engineering sector. So with that, I'll turn the time over to Trevor.
Hi, thank you for watching. This is Resilient Infrastructure by Trevor McDonald. I am the Mountain States Director of the American Concrete Pipe Association, and I'd like to talk about the big picture with resilience. We have a lot of infrastructure going on right now, and there's a lot of programs out there and funding, and resilience is kind of a buzzword, but we want to take a step back, and instead of getting into the technical details of resilient designs, I wanted to take a step back and get a bigger picture of resilience to help us understand what's going on out there. In the Mountain States Concrete Pipe Association, we have a couple pipe producers. We've got Geneva Pipe and Precast. We have Idaho Precast and Oldcastle Infrastructure, and cement producers, Ash Grove Cement and Holcim Cement. Hey, what I'd like to do to get started is I like reading stories, so I just made up a quick children's book, and I'd like to share that with you. I'm titling it The Analogy of the Power Transformer. This story is about checking resiliency against the big picture. Let's see what this story says. Once upon a time, there was a team that designed electrical circuits for subdivisions. They did this so people in the subdivision could rely on consistent, stable electrical service to power their lives. Over 20 years, the team established a good design plan from trial and error. They learned what has worked and used best practices now. So as you can see, there's a power transformer in the background. They're laying those out so that we could have power to power our lives. With a lot of building going on lately, this design team stays busy. They have made good use of their best practices, implementing what they have seen work over and over again, subdivision after subdivision. There's a trench in the background there that you can see that they're laying the conduit down, getting ready to put in their infrastructure. It seems more frequently than ever, people are demanding to get the project done faster and with less resources. And now that most roads and right-of-ways are consistent, the team can do all their design based simply from the road layout plan. And they get plans like what's seen here, and they can say, okay, well, we know kind of where the lots are and the houses are. We don't have time to go out and visit the site. Let's just lay out the circuit. We can put power into this subdivision just based off of this plan, and let's get going. We don't have time to really do much more. So with confidence, of relying on the road design and copying what they have done on previous jobs, the team has kept up with the busy workload. And so they push on, doing the best with what they have. And sometimes the power boxes end up like here in a driveway where it may not be a good fit. And now, granted, the power boxes may come first. Right? The transformers may be there before the driveway, but according to this lot and this owner, they had a little bit of a conflict. But their 20 years of best practices weren't fully tested. The past doesn't predict the future, and the climate is changing. Extreme weather events now occur more frequently. Right? We're getting a lot more intense rain. We're getting thunderstorms that may knock out power more frequently. But we're also getting hotter summers that may require more demand on AC units. And it's not just the weather, right? It's people too. People are changing. Like in the background here, we've got a higher density residential project that went in with farm fields around it. It's not in the middle of the city, but we're starting to see higher density popping up in more of a rural environment that we may not have planned for. The team heard about these future possibilities, right, about climate change and about people changing and residential designs changing, right? But times were busy. Right? They barely had enough time to keep up with development, and resources were spread thin as clients demanded lower costs, too thin to think about the future and what ifs. So they stuck with what has been tried and true for the last 20 years. They thought 20 years is pretty good with subdivision after subdivision. Think of all the subdivisions that they've worked on in 20 years. And that combined pool of experience and knowledge that they can now put in as best practices. Right? And I think they have a good program in place, and they performed well at doing that program. They identified what worked well, and then they just keep doing the good stuff and learn from the bad stuff and keep making it better and better. The big question, though, is, was that their job? Just going after development, keeping up with development, laying out these transformers with the best practices that they had of trying to just plop them in the ground every 1,000 feet or whatever else. Was that really their job? And this is kind of a discussion that I'd like you to think on. And what did they miss the big picture there, maybe? This is the power transformer they've got. Their job was to not just keep up with demand and lay out transformers to, the whatever every 20 houses or every 200 houses get a bigger transformer, or et cetera. And you got to remember, this is a children's book, right? So this, obviously, there's more technical details involved in laying out electrical circuits and subdivisions. But to paint the picture, maybe sometimes we get caught up in the technicalities of our work, and we don't take a step back and look from an elementary view of the big picture. This transformer is in the middle of a floodplain. Right? This is in a managed floodway at the very bottom. And power, electricity, and water don't mix very well. Right? If you look at floodplain managers, I gave this presentation to floodplain managers. From their perspective, they're probably thinking, that doesn't look like very resilient infrastructure. We oftentimes see floodways flood with water. That's what they're designed to do. They're trying to keep the water in that area. So when water comes up, putting a power transformer in the floodway at the very bottom probably isn't the best idea to have stable, reliable electrical service. So back to the question of, was that their job? That's we've got to think, well, if you look at laying a circuit every 1,000 feet or every 50 homes or every 500 homes or whatnot, then maybe so, right? If their best practices was that, and according to the road layout plan that they had, maybe that was their job. But if you look at it from a resilient infrastructure standpoint, maybe we have to look back and see the big picture. and realize that there's a lot of homes depending on that power transformer. Right? On the other side of this, on the other bank, there's hundreds of homes that tie into this circuit. There's many subdivisions that rely on this power transformer. And with resilience in mind, maybe that isn't the best spot, right? We probably wouldn't hurt, since it's a managed floodway. There isn't any development that would be allowed in this area. We probably could get by moving that transformer a little further up the bank, where it may be closer to those development, those subdivisions and those homes, but out of risk of failing or being flooded and shorting out. And I hear, especially now, rumor has it, power transformers are in short supply. Right? It may be difficult to get that power back on if there were an issue there with flooding or whatnot. So let's take this and kind of project it into what we're doing. Are we looking at the big picture with our designs? Are we asking ourselves, is this resilience when we're looking at our designs? Right? And it's a simple question, but sometimes it helps us take a step back and look at the big picture. So what about us, right? What about now? Right now we've got environmental changes going on. Right? That's impacting the resiliency of our designs. Sometimes we have best practices that are established from 20 years back, but the past 20 years isn't really a good indicator of the next 20 years, especially right now. We're looking at the climate change picking up. We look at extreme weather events picking up pace. We look at some of our designs that are being tested to the limit in flooding and in floodplain management, stormwater management. Oftentimes we design to a 100-year event. And now we're starting to see these 100-year events that we designed for happening maybe once or twice a year, right? or more even. In some cities, we're seeing 100-year rain events happen back to back every week in some parts of the summer. So it's interesting to see if are we looking at resilience to feed that into our designs, and are we keeping an eye on the big picture? And what about people? Right, we mentioned people are changing. We are pushing the boundary of high density and hard surface that creates ripple effects. We'll look at some of the things that demands on developers wanting to squeeze more units into area that might be small enough already as it is, but that was originally zoned for maybe lower density. Or what are we doing with active transportation that may change how we look at culverts or pipes and other things? So I gathered some current events. I gathered some news articles and other topics of interest that kind of caught my eye that has a relation to resilience, and I want to talk about those. There's 6 different events that have been going on in my life right now that I thought might be good to share, and we can go through each one of these. So this is a concrete box culvert. It's down in Cedar City in southern Utah. It has stood up to a lot of storms. This news event kind of captured the record rainfall that Cedar City is having, which again goes and plays in with the climate change that we are experiencing. You can notice there's debris around here. The news event was that this was a drainage that came from cedar breaks. There's mature pine trees, tall spruce trees and fir that are coming down this channel and slamming into this drainage structure, which you would think, if it holds up, there's some resilience that's tied to that. So this structure did very well. It held up to back-to-back storms, and pretty intense storms. These were back-to-back storms that exceeded the design on the box. It exceeded the 100-year design, and it still held up well. Here's another one. This was in Utah as well after a record winter where we had development that's maybe pushing the boundary of what is good and developable into some more risky areas that might be a little bit more challenging. These more challenging areas require more attention to detail or maybe different methods and approaches on how we can build resilient infrastructure in that more extreme condition. And I thought it was interesting that the developer, I thought I caught on an interview saying that we've done this in hundreds of subdivisions and never had any issues. And that's kind of the caveat with resilient infrastructure and best practices when we're looking in the rear view mirror, but not looking forward. And that's maybe the word of caution that I'd like to talk about a little further as we discuss these events. This was a failure as well during record runoff. So we had record snow in the winter, and then we had a lot of runoff in the spring, and we were wondering, how is the infrastructure going to hold up? Where are we going to see failures? Where are we going to see flooding? And this was one case where we did see some failure. This was a thin-walled flexible pipe that trees were coming down and debris were coming down this, and the witnesses that saw this fail said they thought they saw a large tree branch that snagged on the thin-walled pipe and pulled it a little bit, and that may have created an opening for the water to then erode around the pipe. But as you can look on the picture, I mean, we can talk about this more as well, but there may not have been enough cover on the pipe as well that may have attributed to the failure. But we have some washouts, some pipe floating up and washing away. We have some pipe collapsing and sinking. This is in a state road in Utah with maybe aging infrastructure that might have older materials that are failing. Again, another thin-walled flexible pipe that might be on an irrigation line. So this, again, with different owners in the right-of-way, sometimes we have a challenge of getting everybody on the same page with resilience and how we can boost the resilience of our infrastructure. And with aging infrastructure, with challenges on can we maintain everything that we've got out there, we might have some failures that cause road closures and sinkholes. In Utah and across the country, we have some areas that are exploding in growth. This is another development pressure, but through the lens of resilience, if we're looking through this with resilience, we can kind of get some lessons learned. This is an area that had extreme growth, and maybe they grew too fast. That they weren't able to keep up with. They weren't able to keep their master plans up to date with the growth and development that's going on, or perhaps they were going fast enough that they didn't know what would be the appropriate size on the storm drain. Here we've got a storm drain that's being ripped out, a flexible a thermoplastic storm drain that isn't quite big enough, and they wanted to beef it up a little bit more and have better capacity and better system because it was undersized. It wasn't serving the community as well as it should have. The ironic thing here is the storm drain is supposed to last at least 50 years, well over 50 years, and maybe even into 100 years. But within 10 years of being put in there, we've got to pull it out and put in some more resilient infrastructure that can hopefully serve the community better for many more years to come. So developers sometimes pressure us into squeezing areas down. This last one talks about not really storm drain related, but another big current issue going on with development are looking for ways to get more for less, and narrow streets are a big topic. We had legislation that passed with pushing the limit on how narrow can we get our public right-of-ways, and what can we do to allow the way of life to be what we're used to with two-way traffic, parking on the street, and the convenience of what we've become accustomed to with our public right-of-ways, but also get them for as cheap as possible and as little infrastructure as possible, and open up the land for more units to be sold, and again, more revenues and more sales and possibly even more profits for the developers. And we end up with narrow streets that Originally on paper, it may have looked like you could get two-way traffic, but after everybody parks on it, you can see in this picture, there's it's not convenient to park in the driveways that are in narrow alleyways out back, and short driveways that barely fit a car, and small garages that barely fit a car. And so they end up parking on the street. And with everybody parking on the street, now there's no room for two-way traffic. And so now you turn this into a one-way road. But there again, yeah, I mean, think of with a fire or with snow plows or emergency services, public services, it gets kind of hard to get around this infrastructure. And again, with resilience in mind, is we see these pressures, we see these current events that are impacting our efforts in creating resilient infrastructure for communities. So Congress is picking up on this, right? And the National Academies even published a book about resilience back in, I think, 2014, that talked about how we can boost our national resilience with all of the infrastructure that we have, and with where we have starting to push the limit of development and civilization. We have a lot of assets, and we have a lot of risk possibly with these assets if we are looking at the face of climate change and what's coming down the road. And Congress is perking up to this. Right? We know that resources are strained. We have limited funds. We have limited, maybe even limited people to go in and revamp our infrastructure. And so anyway, Congress is looking at funding. In the last couple of years, we've seen the federal government boost conversations around resilience in bills. They've talked about this language for more resilience as well. So here we have just text and excerpts from a couple bills recently. And you can see in here, I think the first bills Congress talked about, well, let's look at becoming more resistant to a lot of this climate change, a lot of these natural disasters and extreme weather events. And then in subsequent bills, they beefed that up a little bit and say, hey, we're going to create programs and we want funding for this. And in the most recent, then they started allocating a lot of money toward boosting our national infrastructure, not just at the federal level and on federal highways, but down to communities and local tribes and counties, etc. So part of that involves FEMA. They have directed FEMA to look at the country and identify areas that may have some inadequate resilience or inadequate infrastructure through the lens of resilience, right, from a resilience perspective. So FEMA just recently has identified and designated resilience zones where we may have a little extra priority and some emphasis placed on funding and resources that are more readily available for these areas where they can upgrade their infrastructure, they can upgrade their plans on boosting that community's resilience. The Federal Highways has created a website now too. They call the DOT Navigator. In the DOT Navigator, they have culminated all of the federal funding for a lot of DOT grants and programs that the federal government has now allocated funds toward, where it's all in one place where you can search keywords on a project that you're looking at. So if it's a storm drain project, we could just search for storm drain or culvert or surface transportation. If it's an active transportation project, you can look at active transportation, etc. And it brings up all of the applicable grants that you could look through and see which ones might apply to the project that you have. So good user-friendly interface and a useful tool to know what funding is out there. Federal Highways has one that's very pertinent to resilience, and the one that I think is the most applicable is the PROTECT program. Congress allocated quite a bit of funds into the PROTECT program, and here you can see that the purpose of this program is to help make surface transportation more resilient to natural hazards. In the PROTECT program, they provide $7.3 billion to the state DOTs for the state highways, but there's also a discretionary and competitive grant program that provides $1.4 billion to local governments and planning organizations, Indian tribes, counties. That's where we can look at boosting, the community infrastructure as well. So how can we transform our engineering? The purpose that I want to bring this to is what can we do as engineers? This presentation is geared toward design engineers in storm water and drainage infrastructure. I wanted to take a look at what are we doing? Are we transforming with everything that's going on? Are we changing with the climate? Are we keeping up with the development demands? And are we doing it fast enough that we can still stay resilient? So if we go back to the analogy of the power transformer, right? They had good best practices. They had 20 years of great things. I didn't think anybody, while reading through that story, had any complaints with what they were doing. But afterwards, looking at the impact of that, then we can see that maybe that wasn't the best idea, right? Maybe we missed the bigger picture by putting the transformer at the bottom of a floodplain, and maybe we need to take a step back and look at what the big picture is. So just to give kind of a summary of what's going on, I believe, just coming from municipal government and looking at a lot of development reviews over the last 8 years or so, I feel like what's going on is we're taking our best practice that we learned on a good project, and then we are copying that as a template for this new problem, and we're going to say, hey, look, that worked really well here. Let's just go through the same method. So we take that past solution and we project it onto a current problem that we have. And then we run hydrology counts. We try to get the rainfall data, what's going on at that particular location. We'll look at the layout, the plan and profile, maybe update, with just the slopes across the site, we can update the profile with the street layouts. We'll just update the new road layout in the hard surface areas. Then size the hydraulic structures accordingly, and copy the notes down then on the old drawing and maybe change the pipe sizes is kind of what I'm seeing. So it's almost the exact same notes. We're looking at a real similar method, and that method gets replicated over and over and over again. But maybe what to look out for, some words of caution, is not every project has the same context, right? If you refer back to that project where the developer is pushing up the hillside into the mountain, and maybe they've done subdivisions hundreds and hundreds of times, right? But maybe this one had a little different context. Maybe this one had a drainage creek above it that they weren't used to dealing with on the slope, or there could be a plethora of other issues, right? So the context is important, and taking a step back and looking at the big picture on every project, maybe we can get a better idea of the context that we're dealing with. And we can go out and visit the site. We can look at the project conditions on the site and see if there's anything that is different with this site that we maybe need to take into account. If you look back at the story that we told with the power transformer, the crew was too busy to really get out there and look on site of what's going on. And so they just went off of the road layout plan, and they thought, well, this is good enough with the road right-of-way that it is, mostly consistent. We can get most of our work done without any issues. Just going off of this plan, it'll save us time. Right? Sometimes we're hearing of development designs being taken place all from the office, and we're looking at Google Earth, we're looking at maybe a quick drone study, an aerial study, but we're not really out there looking at the conditions of the site and getting a good feel for what's going on in the project. Taking a step back, looking at the big picture of, okay, what may be impacting this project that I need to be aware of. And we kind of work in silos. Right? So with these past solutions that we're pasting in as a template to a new project, sometimes we mentally think, I've already solved this. I'm just going to go through the same method, and we've got this. I don't even really need to talk to anybody. This is the agreed way on. It worked last time. Why won't it work this time? And we forget to collaborate and talk with others on what's going on. So back on that story with the power transformer in the floodplain, maybe it would have been nice if they collaborated with the community floodplain manager, and saw where the floodways were. That might have triggered. That may have helped them look at the big picture of maybe a power transformer right at the bottom of a floodway is not the best idea. And that, that hopefully can help us overcome some short-sighted assumptions that we have, or the incomplete picture. The more we talk to, the more we collaborate, the more we get out there and see the big picture, and hopefully that can help us see a complete design. With development going on and the pressure of our clients as well, I feel this more than in years past, with developers wanting to do things faster and cheaper. We might have a bias toward our clients' views, right? Of being, we're looking for the fastest, cheapest option. But maybe the fastest and cheapest option is not the most resilient option. Okay, and so we need to kind of think about how can we get our clients to understand what's the most resilient option for this, and help sway them toward resiliency. So how are we thinking down the road, right? We want to look at more than just the now, right? I think that developers and landowner tendencies tend to focus on, well, what can I do to develop this site and get me through the warranty period before I have to turn it over to the city and sell it, and then I walk away. But infrastructure, especially in flood control, infrastructure usually lasts 50 years, right? Generations. It can last 100 years. And we need to look at, are we looking at those future drainage scenarios impacting the site? Are we looking at full build out? And full build out sometimes is a debatable case. Are the master plans reflecting what full build out really might realistically reflect, right? Are we looking at all upstream that might be what upstream looks like in 30 years or 50 years from now? And then are we looking at the impact of downstream, not only today, but also 50 years from now, and what the project that we're putting in is going to impact and cause, to impact downstream 50 years from now. And we've got to look at, will it cause overtopping, right? Do our improvements or do our infrastructure cause problems? Is it going to be resilient in the face of scour and fire and abrasion and buoyancy? And is it going to stay put, or is it going to wash away? So a good way to do this would be to look at planning, right? And are we planning accurately? Do we have our master plans that are up to date? Do they reflect current projections? Here's kind of an image of the rainfall intensity maps as well. Are our assumptions and our planning reflecting current conditions? There's rainfall intensities that are changing with climate change. We're looking at a now more intense rain events that might push the threshold of our 100-year rain to maybe our 100-year rain events are now a 20-year rain event. Or are our system capacities up to date? And are we looking at the right capacities for the infrastructure that we're putting in, or are we out of date there, thinking that we can contribute into a canal or a creek that might already be full? And is the zoning up to date, or does the zoning reflect reality? Oftentimes we're seeing a lot of zoning get higher density, and what we thought was a low density hillside now turns into a lot of hard surface and a lot higher density that has a lot more runoff, and that impacts the storm drain infrastructure downstream. So with the future project conditions, right, what will we see, and how can we design the infrastructure to handle these conditions? Are we considering debris, right, or scour? Sometimes there's a good scour impact that could wash away a lightweight culvert that could float up, right? Are we looking at the flammability? And this one oftentimes gets overlooked because storm drains considered, they're looking at rain events, but usually there's also lightning and wildfire around some of these rain events. Even in the urban environment, there's some storm drain that is, we may need to consider what kind of materials are we considering to be resilient in the face of a threat of fire. And buoyancy and flotation, right? With lightweight we're trying to get thinner, lighter, and cheaper products. Sometimes thinner, lighter, cheaper products in the ground pop up out of the ground when we're not expecting it. And right when we need to evacuate through a road, the worst thing we'd want is a culvert popping up and blocking the way. And there's active transportation, which is another one. Oftentimes, trails and bike routes move through greenbelt areas and drainages, and they like to go through and alongside creeks, which means our culverts now that were designed to handle just the creek flow might need to be a little bit bigger to handle bicycle flow and active transportation. So those are conditions that maybe we need to start thinking about, right? And looking at not only today, but 50 years from now, is there going to be an impact that we need to consider? And what can we take into account to make our infrastructure resilient to those impacts? So are we designing with the right materials in the right application? I mean, when we have a scour application, are we looking for a heavier material that can maybe stay put? Or if we've got threat of fire, are we looking for a storm drain that isn't flammable, right? Are we choosing the right materials that won't burn up? There's some thermoplastic pipe that is flammable, and when it burns all the way through. Right? Or are we, if we have a low cover, shallow storm drain, or saturated soils, are we looking at a heavier product that can stay in the ground and not float up or wash away? So those are the questions that we need to be asking to build resilience into our projects. If we go back to the Cedar City picture that we talked about, where they had back-to-back storms that exceeded the 100-year rain events, and we had a box culvert there that didn't move, even though the water level raised up over top of the culvert. Debris was slamming into the culvert. They had full trees. It still stood up to those back-to-back storms that exceeded the 100-year design that it was built to, and it was able to bounce back. That's the resilience that we want to think of when we're looking at how can we keep our infrastructure in the ground, how can we let it serve us for the design life that it was intended to. So here's another example of looking at the bigger picture. Sometimes it may not even require infrastructure. There's a hot topic now is, what if we leave it natural and leave the bank open? What if we don't bottleneck the stream, right? Sometimes bottlenecking the stream leaves problems that cause flooding. This is an example. I shot this video showing a 10-foot by 8-foot box culvert that got plugged up. You would think that that would be a big enough box looking at the debris that might come down through here, but 2 full juniper trees got plugged up in the box culvert, and it's right by that sign. It's right in front of that sign. That wasn't enough, and that created a bottleneck that then flooded new commercial development just downstream of that might have been less of a risk if we didn't have that stream bottlenecked. So maybe resiliency is looking at the bigger picture of, well, maybe what if we leave this open and alleviate the risk there. So that another bigger picture could be just being aware of the infrastructure that's there. This is a development plan showing a detention basin with a water transmission line that runs right through the bottom of it. There's some room for that water transmission line to be in the street. It could be routed around it. Later on, that's what they did. But their first proposal is, we're going to have a detention basin here, and they didn't look at the big picture of, well, there's also an important water transmission line that has some valves that might be right there in the detention pond. Silos, we worked at collaborating with others, getting the big picture, visiting the site. This all helps with building a good resilient design. So how do we assess project resilience? I think, okay, that we understand the importance of project resilience, but it's sometimes we say it's out of our hands, right? Sometimes it's the city's requiring these standards and we've just got to go with it. But honestly, in my experience working with a government and being in government, uh, I've only heard of maybe 2 times where an engineer or a developer has come and said, hey, we don't like your standards. We think that based on our assessment, we need to beef up your minimum standards and we need to put in something a little bit better, a little bit bigger. That typically doesn't happen. Usually what we hear are, why do we have to meet your minimum standards? They seem a little excessive, right? And why can't we use cheaper, or faster or lighter materials? Why can't we? And it always ends up being something that erodes away the standard that the city has set. So good communication, right? I think from my experience, when an engineer comes and tells me, look, we did an assessment, we think that we need to have a variance that exceeds the city standard. Can we do that for this project? We feel like it'll be more resilient based on the risks that we've identified there. I think if that's communicated to the city, I think they would be willing to go above and beyond the minimum standard to put that in. There's also a risk occurrence matrix. Right? So oftentimes we've looked at risk, and this is the matrix here where you look at the likelihood of an event happening or a threat, right? And then the impact of that threat on the infrastructure, and then that would generate the risk. So for example, and these scenarios can go quick. You can do it over and over again through the design process. But let's look at a culvert on the side of a road, right? If we're looking at, we want to put in a thermoplastic culvert on the side of a road, there's some grass or some brush on the side of the road too. There's maybe an unlikely risk of fire, but there's still the chance of fire there. We're here in Utah with climate change. We're going to have more extreme summers and hotter, drier periods. I wouldn't say it would be rare like back east where it might be more green, but there might be an unlikely chance of fire on the side of the road. However, if there is a fire on the side of the road and the grass burns, it has a major impact on the thermoplastic pipe that's flammable, right? A major impact crosses over with unlikely or a rare event. You intersect those and you get this area that's a high risk. You have this high, even in an unlikely event, it's still kind of a high risk design. We want to stay out of the high risk projects. And I feel like development pressure is pushing us more into the high risk areas. But let's look at how we can be more moderate risk to low risk. I think that's kind of the dividing line for resilient infrastructure. So when we want to look at a culvert under a road, maybe we say, well, thermoplastic pipe is at a high risk. So maybe we need to look at a different material that is not flammable, right? They can last better or hold up better to fire. And life cycle cost analysis. This one is often done, but this one is often done a little too early. I think we need to go through the risk occurrence matrix first to decide, what's our project going to be looking like, and then those that are at a low risk or a moderate risk solution on the project, then we can look at life cycle cost analysis and define, which one has the best life cycle cost that is a lower moderate risk, and we can go with those materials or those methods to help boost project resilience. So we want to look at the bigger picture questions, right? Some big picture questions are, what material or method would hold up best against the future on this job? We talked about, let's get a more realistic view or perspective of what's going on 30 years from now, right? Or the life of what that infrastructure is designed to be. Now let's think down the road that far and to see, would this material hold up through all of those years instead of just, will it hold up now or through the warranty period, and then let's call it good, right? Another question is, how can I coordinate with others involved in the project to make sure my plans work with the big picture? Sometimes we think, right, that we have all of the solutions. We're just going to go through that same method. We'll run through the process, and the last project got approved that way. We should have no problem with this project, and we're off and running. But then we forget, like the power crew forgot that, maybe we need to check with a community floodplain manager before we put our transformers where we want to put them. And how can I use risk assessment to approach my client or governing body to help them invest in the more resilient solution? With the risk assessment, again, we can say, based on our assessment, we feel like this project is high risk using this material or this method. We recommend going with something a little more beefy or something that can build resilience into the project and make your project last. How about we go with this and see if we can get them to lean more on the side of resilience instead of just the fastest, cheapest way to get the project done. So in summary, we talked about climate and people are changing, right? With the past, sometimes we have well-established best practices, but that past 20 years isn't really what the next 20 years looks like, in my opinion. I think we're going to see some more challenges ahead, and we've got to keep our eyes open. Right? We've got to be aware that the environment is changing. Existing infrastructure is insufficient. Right? We have aging infrastructure, or sometimes we've got infrastructure that possibly is not the right material or was not put in the right way. Congress is catching on. They're seeing that this is a nationwide issue, so they've provided funding. Even though we may not have the resources available now, Congress has given us some funding so that we can get after this and we can get more projects done with the limited resources that we have. And specifically, projects that are going to boost our community's resilience, has grant money tied to it. We should look at risk assessment, right, including the material selection for the job, and try to avoid the high risk that might be inherent with our jobs, and we may not even realize that. But as we look at the big picture, we can see, that can help us identify those areas of high risk. And then coordinate with all the stakeholders on the job, right? Don't get trapped into the silo mentality of, yes, we've done this 100 times, we don't need to really get collaborating with others, but get all of the stakeholders involved, get a good idea of what the big picture is from their perspective as well, and help build that resilient design, taking those perspectives into account. The big thing that's the simplest is sometimes we just need to think about resilience. Oftentimes we're pushing along in our work and we forget about resilience, and we're just driving the bottom line with how can we do it faster and cheaper, and thinking we did it faster and cheaper than the project before. That's a good design, but maybe we need to look at how can we do it more resilient than the project before, and how can we build in resilience into our project. And it's really all for the idea of leaving a lasting legacy. We really should strive to build the infrastructure to last for generations, so that our children can enjoy it, right? So generations after us can really enjoy the design that we have. When we're ripping out infrastructure before even 10 years, right, then that's not the resilience we're looking for. We want to put something in the ground and be proud of it for communities to rely on for generations to come.
I want to thank Trevor McDonald for sharing this message about resilient infrastructure and leaving a legacy. For more information about this topic or any Oldcastle products discussed in this presentation, please email me at jason.allen@oldcastle.com or visit oldcastleinfrastructure.com.